Hello. So this lesson is about similar figures, okay? If you take a look, for example, at the robots, they are similar robots, okay? So that's what we're going to be talking about today. So first thing we have to talk about when we do similar figures, though, is that we need to talk about the differences between figures that are exactly the same and figures that are only similar, okay? All right, so figures that are exactly the same are called congruent figures, right? They're congruent. That means that everything about them is the same. Their angles are identical. Their side lengths are identical. And the symbol for congruence is actually right here. It's an equal sign with a little swoopy thing on top of it, okay? That swoopy thing is actually called a tilde, kind of like in Spanish, okay? It's what's over the end that makes the nye sound. Similar figures, though, are not identical. They're only similar, okay? Their angles are equal to each other, but their side lengths end up being proportional. If we go back and look at the robots, just to take a look, this lighter color robot right here, right, is identical or equivalent to this one, right? They have the same exact details about them. They might be in different positions, but they're the same details. This lighter blue one and this darker blue one, though, they're not equivalent, okay? They're not congruent, but they are similar. So there are some features about them that are the same, but there are some features that are also different, okay? And that's what the difference is between congruence and similar, okay? So with the shapes and the things that we're going to be doing in geometry, again, all of the angles are the same, but their side lengths ended up being proportional, and that's what we're going to be talking about. Probably the hardest thing that you're going to have to do is just setting up those proportions. And I will say that when you set up the proportions, as long as things are lined up together, and it's all the same. Similar, not the same, right? But as long as everything is lined up together, it is okay. So if you take a look at these three fractions, for example, these three different proportions, okay? If we were going to go solve them, we would cross multiply. And if you look at this first proportion, I'm going to be multiplying 5 times x. Notice how my line, right? If I cross, I draw an x over it, okay? For this one, I'm multiplying 5 and x. And then 7 and 10 are diagonal from each other, so I'm going to be multiplying those as well. If I come up here and look at this fraction, notice as I start to draw the big cross multiplying bar, the big x, I'm going to be multiplying 5 and x and still multiplying 7 and 10. Okay? This one, even though the 5 and 10 aren't on the left side, the 5 and 10 are on the other side, again, as long as I have things lined up with this fraction, I'm also multiplying that 5 and x together, okay? So it doesn't matter exactly how you set them up when you go to do the cross multiplying part, okay? And you go to do, both of these. Whoops, sorry about that. Both of these aspects, right? And you go to actually solve it. But all three of these fractions end up being the same because you're multiplying the same numbers. Let's take a look at number 5. One of the things, or slide 5, one of the things that you're going to have to do is determine if things are similar to each other, if that similarity actually exists, okay? So if you take a look at these two triangles, this blue wavy one and this red polka dot one, they look pretty similar, right? They look pretty similar. One's a little bit bigger than the other. That's okay, but they look like they're kind of in the same shape-ish, right? The same kind of dimensions. And so what you have to do is you have to set up those fractions, those proportions, and see if they're the same. And so one of the ways that you can do it that's pretty easy is to just divide the sides. So starting with the blue one, we're going to divide 9 by 4.8. So that's right here. We get the decimal 1875. Then we're going to do 4.2, and notice how on this triangle it matches, it kind of lines up right with the 2. So 4.2 divided by 2 is this decimal right here, 2.1. And then 10.5 divided by 5 is also 2.1, excuse me. But notice how these aren't all the same? If those decimals were the same, then these would be proportional, but these decimals are not the same, so this is not a similar shape. These are not similar, okay? They're not. And then the last little detail that we talk about is, I don't know if you remember doing like side, 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 side angle, side, all of those kinds of things. But you can use those triangle congruent aspects to see if similarity exists in stuff. And so notice this little triangle is on top of this triangle. And so angle B is equal to angle E. Angle C is going to be the same on the little triangle as it is on the big triangle. And then obviously if you add those two angles together and subtract from 180, you know you're going to get D and A to be the same. And so these are similar because of angle, 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 okay? If you take a look at this over here, if we were going to do some dividing, 10 divided by this and then 12 divided by that, since the two angles are the same, as long as those fractions are the same answer, then this would be by side angle side. If it's not the same fraction, then they're not similar, okay? And then for this one, remember we did vertical angles, and so this little angle in here by n and this little angle over here by n. So these could potentially be similar as well by side angle side. Okay. Let's go try some problems and actually see what it's going to look like on paper. Okay. If you go into Canvas on your modules and you click on today, the similarity notes, this is just the link to what we just got done doing. This is, however, what we're going to practice. So we're going to go ahead and click on this. It's going to take you to the assignment, which is the similar figures, okay? Go ahead and load this in a new window. I will tell you, this is an actual workbook assignment from your workbook. And so normally you would turn in one Google Doc with your pictures. And what you're going to do for this one, instead of one Google Doc, here is the Google Doc. You're just going to take your pictures and insert them right here into this Google Doc and hit submit. All right, so these are workbook pages. This is page 167, 168. There's only a couple of problems that we're going to be doing. We're going to do number 3, 4, 8, 9, and 10. And then on workbook page 171 and 172, we're actually going to go do all of them, okay? All right, so on workbook page 167, we're going to start with numbers 3 and 4. And so let me just kind of give you a heads up of how this is going to work. Keep in mind, right, no work means no credit with Hunsicker, so make sure that you're writing them down. But definitely get a calculadore. You're going to need a calculator of some sort because ain't nobody got time to go figure out some decimals, okay? All right, here's how this looks. Ready? Number 3. So it says, all right, check this out. These two figures are similar to each other, okay? So this figure right here is similar to this one. They're telling you that. It's similar, all right? We're going to go find the missing length. And so what we're going to do is we're going to do two things. We're going to label our picture first, and then we're going to set up a fraction. Okay, so let's go label our picture, and then we're going to set up those proportions, okay? All right, so I'm labeling my picture, and it says I want to find WZ. So I'm going to find this side right here that I just put a zigzag line on. So I'm going to label that with a missing letter. Let's call it X, okay? All right, so I labeled my picture. Let's go set up some proportions. So when you set up proportions, remember they're fractions. So you're going to need a fraction line equal to a fraction line. So if you ever hear me say line equals line, that's what we're doing, okay? Here's a fraction that I'm going to set equal to a fraction. What we have to do is decide what numbers are going to go in these spaces that are right here. Okay, that's what we're going to kind of do. Let's figure it out. Now, I'm kind of a little on the strange side if you haven't figured that out yet, right? But I like to do my fractions in the same kind of manner every time. And so what I tend to do is I look at my one shape. So 0.7 and x, so I'm going to put those together on one fraction. Okay, and then on the other fraction, I'm going to put the same numbers that are in that same position from before. And so luckily, these two shapes have not been spun around. They're both in the same or similar position. And so on this side, even though there are three numbers, we're only going to use these two. Okay, and then I'm going to show you another way to kind of look at it in a little bit, okay, because these letters can help us figure that out. So now all you do is cross multiply, okay, so 2.1x is equal to 3.15. Let's divide by 2.1. Final answer, 1.5. Okay, let's go do number 4, or at least get it set up. So number 4, same thing. Let's go label. I'm looking for JM, so I'm looking for this zigzag side. Let's call it an X. So I'm going to do line equals line. On my first shape, though, I have three numbers, so I'm not sure which numbers to use. So I'm going to go look at my second shape, and I have 26 and 22. So 26 and 22. The side that matches the 26 happens to be our X. So I need to make sure it's lined up next to it. The side that matches the 22 is going to be that 33. Same thing, cross multiply and divide. Okay. Number 8, we have two stores that are shaped like rectangles. So go draw some rectangles. Okay. We talked about Hobby Lobby today being put up next to that Costco I'm so excited about. It says store A is 125 feet long and 80 feet wide. Store B is 100 feet long and 60 feet wide. And we want to know, are they similar? So you're going to put 80 over 125. Is that equal to 60 over 100? You're just going to go divide in your calculator and see what happens. Okay? All right, so I divided my two fractions and take a look. I got different answers. That means that these are not similar figures. They are not the same. Okay, definitely not the same. Question number 9 is going to be a bonus question. I want you to just kind of take a minute and look at it and think about it. See if you can come up with the answer. Number 10, same thing. Let's go label it, right? We're trying to find BC. And so I'm trying to find this side right here. And so I know that 33 over x is going to equal 44 over 48. It's just a matter of you cross multiplying and dividing. All right, so on workbook page 171, again, your assignment is to do the whole thing. If you take a look at page 171, number 1, one of the things that is easy to do is to just write some numbers down, right? And so part of that labeling process is what you need to be really careful about. So let me show you how these letters come in handy, okay? So this is telling you that A, B, and C might be, because you're trying to determine if it is, but it might be similar to D, E, F. And so here's what you do. As you start at point A, okay, and you go around the triangle, so from A to B to C, I went over the 24 line first. So I'm going to put 24 on top. Then as I go over on my other triangle, D, E, F, so if I start at D and go E, F, I went over the 18 first, which is why the 24 and 18 should get lined up together. Okay? This is the same as the last question. You're just going to divide and see if you get the same answer. If you take a look at question number 3, this is the exact same thing. Again, use those letters to help you figure out which sides are going to be similar. Okay? The last two questions that I wanted to go over with you are number 5 and number 6. And I will tell you that this is going to show up on that riddle page as well. The easiest thing to think about is that the little triangle is sitting on top of a big triangle. And so if you pull it apart, you have two separate triangles. Your little triangle is x by 12, but your big triangle is going to be 28 by 24.